Distance between 2 points. In the diagram below, state the coordinates of A, B and C and the distances AB and AC. So if we look at A, that's at -9 and 7. If we look at B, that's at 1, 2, 3 and 7. And if we look at C, that's at 3, -2. So the distance AB, because we can see that this is just simply horizontal, we can just count squares. So if we count those squares, we'll find that the distance between them is 12. But there is another way of doing that, and that is we know the x-coordinate here is 9 and this one is 3, and if we do 3 take away -9 we get 12. So AB is 12 units. We also want AC. So AC is this distance just here. Now, BC we can do by counting, or by the fact that we know the y-coordinate here is -2, the y-coordinate here is 7, and therefore this distance is 9. And note, this is a right-angled triangle. We know this distance here is 12. So we can use Pythagoras' theorem to get AC. AC is the hypotenuse, so AC squared is going to be 9 squared plus 12 squared. Let's just calculate that. So 9 squared add 12 squared is 225. And then AC is the square root of 225, which is 15. So AC is 15 units. Now let's look at this in general. We have 2 points, A and B, and we want the distance between those 2 points. So what we can do is form a right-angled triangle, and then we're going to make use of Pythagoras' theorem. Now the coordinates here are x1 and y1, and here they're x2 and y2. In order to work out the x distance, the horizontal distance, we just subtract the x coordinates. We saw that happen before. So, for example, if we know that one point has an x-coordinate of 6 and the other one has an x-coordinate of 3, then the distance between them horizontally must be 3. So this is x2, take away x1, subtract the x-coordinates. In the same way, to get the vertical distance, we're going to subtract the y-coordinates. And then if we call this d, it should be clear that d squared is going to be x2 minus x1 squared, so the horizontal distance squared, add y2 minus y1 squared, and that's just Pythagoras' theorem. Therefore the distance between the points will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, this formula can always be used for finding the distance between 2 points given, but very often I don't use it. I tend to just use Pythagoras' theorem and draw a diagram. But we'll see both of those approaches in the examples to follow. So we want to find the distance between these points. So if I use the formula for the first example, let's say that this one is x1, y1, and this one is x2, y2. Then d is going to be the square root of x2, which is 6, take away x1, which is 1, squared, and then y2 is 13, take away y1, which is 1, squared. So that's the square root of 5 squared plus 12 squared, which ends up being the square root of 169, giving us that d is 13 units. Now, as we've seen, it's easy enough to use this formula, but the way I would normally do this is to draw a quick sketch. So if we say -3, 1, and 7, 4, and we want the distance between them. So I form a right-angled triangle, just like this. Looking at the x-coordinates, -3 going to 7 is 10 units across. The y-coordinates, 1 going up to 4 is 3 units up. Then using Pythagoras, because d is the hypotenuse, d squared is going to be 10 squared add 3 squared, which is 100 plus 9, which is 109. So d is going to be the square root of 109. Now I've already done that. We can see it's 10.44 to 2 decimal places. So let's put that in. So if we say 10.44 units to 2 decimal places. So given this, we want to find the distance AB and BC. So we want this distance here. So form a right-angled triangle, and I can see that's 1, 2, 3 units across, and 1, 2, 3, 4 units up, and we want D. So D squared is going to be 3 squared add 4 squared, which is 9, and 16, which is 25. So D is going to be the square root of 25, and that gives me 5 units. Now we want BC. So this distance here. So I'm going to form a right-angled triangle like so. Now, how far across have we gone? 1, 2, and another 5, so that's 7 across. And then 1, 2, 3, and another 10. So that's 13. Let's just check that. So 10, 11, 12, 13. And let's call this D. So D squared is equal to 7 squared add 13 squared. And let's just calculate that. So 7 squared add 13 squared gives me 218. And therefore D would be the square root of 218. So let's square root our last answer. 14.764 and so on. And if we give that to 2 decimal places, that will be 14.76 to 2 dp.